values, value types, and variables. In this lesson, you're going to learn how computers work and what are values and value types, what are variables and why we need them. And you're also going to learn some common value types in Blueprint. There are three most important parts in any modern computer. So when you open a modern computer, either a desktop or a laptop, you will see CPU, the brain of the computer. You will also see RAM, which is the primary memory module, and hard drive, which is the permanent storage. If you want to create a Word document, you need to have the Microsoft Word application. So you first have to download and install the Microsoft Word application into your C drive or D drive, any drive. In my case, it's my C drive, program files, blah, 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 blah. And when you open the Microsoft Word application from your local drive, the application, the data, and the application all loaded into the RAM, the computer primary memory. And you are actually working with the application and the data in the computer memory. Data including text you're typing and images. An application also contains instructions our CPU needs to execute. For example, when you open and close files, when you change text, when you copy paste text, when you delete, save, and quit your document. Everything you do, it happens in your computer memory. A video game, a computer game, is also a type of application, so it works the same. When you want to play a computer game, you first have to download the game and install it on your local drive. When you play the game will be loaded into your computer memory. The game contains also both data and instructions, just like any other applications. And CPU is responsible for executing the instructions and processing the data in the computer memory. So everything is happening in your computer memory. So computer memory is extremely important for your computer to run any applications or games. Computer memory are divided into memory locations to store data, and every location is like a drawer. Text, numbers, images are stored in the drawers, like this. Different type of data needs different number of drawers to store. For example, if you want to store a single number, probably one drawer is enough. If you want to store a big image, probably it takes more than 8 drawers to do that. Since our CPU is responsible for accessing, processing the data stored in our computer memory, it needs to be able to locate the data. Every drawer, every memory location has a label, which is a binary number. Basically, is a sequence of 0 and 1s. CPU can make use of these labels to identify where the data is stored in which location. CPU reads data and instructions from computer memory into CPU, process them, and save them back to the computer memory when it's done. Now, the applications or the games are developed by developers. Developers code, write instructions to tell CPU how to store, access, and modify data in memory. However, developers hate binary numbers because it's not really for human, especially if you got so much data you want to store. Therefore, we need something for human. We use variables to hold data in memory and use data types to request the amount of memory for the data. So basically, variables are friendly names of this label, this memory address. Under the hood, the programming language will map these names to these memory addresses. And we developers, we only need to work with those names. Well, let's talk about a little bit more about data. Data, which is information, is also called values in programming. For example, numbers are values. The whole number, the decimal number, they are all values. And there are also text, like the name of a hero, Mario, the name of a sword, like Dragon Sword, the name of food, apple, the name of drinking, water. They are all values, text values. And then there are objects. You've learned that in Unreal Engine, everything in the game level is an actor. An actor is an object. So a player is an object. An enemy is an object. A rock is an object. A sword is an object. A cube is an object. However, these data, these values, they are different. They require different amount of memory space to store them. For example, for storing a number, probably you just need one memory location. That will be enough. One drawer will be enough. For storing an object, probably you need much more memory space for that. So in our next slide, we are going to talk about the value types. Different value types requires different amount of memory space to store the value. And these are the common Blueprint value types used in the Blueprint visual scripting. The Unreal Engine official documentation website has a list of common value types. For example, the Boolean types is for holding a true or false value. What is a true or false value? For example, you can create a variable called hasSword. If hasSword is true, then the player has a sword. Otherwise, he has no sword. Open your first-person template project. If you don't have one, you can create one. Then go to Content Drawer. Under Content, you can create a folder or any folder. Just create one. I have mine called Playground. And inside Playground, right-click. We can create a Blueprint class. We have to pick a parent class. Now I'm going to use actor. Then I will name it BP underscore, for example, player. On the left side of the editor, close to the button, you see a section called variables. If you click on the plus symbol here, you can create a variable, and let's name the variable hasSword. And you'll notice that it allows you to choose the value type. You can also click on the variable and then go to the details panel. If you click compile, and it allows us to give it a default value. So if it's not checked, then it's false. If it's checked, then it's true. Byte, integer, integer 64, and float are for storing different numbers. Like byte is for 0 to 255, and integer is for integer numbers. And then for bigger numbers, we use integer 64. One of the most used value type for holding number is the float. We use float to hold decimal numbers. Now let's create a new variable called health. And we can change the type to integer. You can also change it on the details panel here. If you compile, you will be able to put a default value. For example, the default health is 100. Then we have name, string, and text for handling text values. I know it's a little bit confusing because if you look at the description, name is for identifying something in the game, string is for characters, and text is for displaying text, especially text which needs to be localized. For now, you can just use string to hold text values. In the future, you will be able to learn the differences. Let's create a string variable. We can name the variable sort description, for example, and then we can change the type to string. And now you cannot change the default value. You have to compile it first. A grade sort. Alright, you just learned how to create variables to hold numbers, text, and also Boolean values. These values are called simple values. So basically you see in the memory, they are stored in a certain memory location. And as a developer, we can use the variable name to refer to the value stored in the memory location. We don't have to remember or have to use the binary memory address. However, sometimes we need to store more complex values. I hope you still remember that in our game level, every actor has a transform property, and we can change their location and their rotation. And these value types, they are called structs. So the vector, the rotator, and the transform, they are actually simple structs. However, they store more than one values. For example, the rotation, it has the X, Y, and Z value. There are even more complex structs than the simple structs. In this lesson, we are not going to talk about that. Let's try to create a transform struct and name it as my transform. And we need to change the type to transform. Don't forget to compile. Then we can put in location, rotation, and scale. Alright, let's talk about the last value type of this lesson. It's a reference value type. It's called object reference. So we can create a variable which is a reference and a reference to another object. I know it's a little bit abstract, but let me show you in a real example. Let's close the current blueprint class we are creating and go back to the content drawer. Let's create two new blueprint class. The first one, let's select character as the parent and name it BP underscore player 1. The second one, the same. Let's use character as parent and name it BP underscore player 2. Let's open the first player and create a variable called player 2 and change the type to object types, actor, the first one, object reference. Compile. Now we can close BP player 1 because we cannot do anything over here. We need to select actor in the viewport. However, before we close this blueprint class, there's one option which is very important. Make sure you select player 2, and on the details panel, there's an option called instance editable. You have to check this. You can also go to the left side and next to the name of the variable, there is an icon which is a closed eye. If you click on it, you notice that it just checked the instance editable option. This option has to be checked. Otherwise, when we select the BP player 1 in the viewport, this variable will not be visible to us. Don't forget to compile it. I already did. And then we can close BP player 1. Now back to the viewport. Let's go to content drawer and drag and drop these two blueprint classes into our viewport. When we do that, we actually create two instances, one for BP player 1, another for BP player 2. And you can find them in the outliner as well. However, because we didn't put any shapes in any of these class, we only see some lines. But that's okay. So click on BP player 1. On the details panel of BP player 1, all the details are shown here. Click on General. It will filter some information out. And then you will find a default section where you can find the player 2, the variable we created. Click on the drop-down menu. You can select BP player 2, or you can search. You can also do it differently. Just close it and then use this picker. If you click on it and then go to the viewport and click on BP player 2. We just selected the wrong one. Let's do it again. Alright, still not the right one. Now it's BP player 2. Because there's no shape, so it's a little bit difficult to select. But anyway, now the variable player 2 is pointing to the actor BP player 2 in the viewport. However, it is very important for you to understand that we will change in this value for the actor BP Player 1, which is an instance of the BP Player 1 blueprint class. We will not change in the blueprint class, we will change in the instance. So if you go back, click on the content drawer and open BP Player 1 blueprint class again, click on Player 2, the variable, you'll notice that there's nothing changed in the class. Alright, this is the most difficult one, the object reference. However, it is one of the things we are going to use a lot in our future game development. Alright, we are at the end of this video. Some reminders for you. When an application is running, everything is loaded from your local drive into the RAM. RAM stands for Random Access Memory, which is our primary memory of our computer. However, RAM is temporary storage. So if you turn off your computer, all data stored in the computer memory will be gone. And that is the reason why when you are working with your Word document, don't forget to save it from time to time, because then you will save all your data into your local drive. Next time when you switch on your computer, or if Microsoft Word application crashed, you would be able to find your data back. When you're playing a video game, the video game normally also offers you to save your progress from time to time. Values are data or information which are stored in computer memory. So the value type of the value determines how much memory space is needed for storing the value. Variables hold or refer to values stored in computer memory. Variables are only used by developers to make the life of the developers easier. Once the code is compiled, variables don't exist anymore. CPU will simply use memory addresses to access the values stored in the computer memory. Alright, that is all for this lesson. Thank you very much for watching, and I'll see you in the next one.